Hey y'all, welcome back. This is week 7. We are almost done with distance learning. This week we want to review quadratic graphs. Remember, quadratic equations we see in standard form like this: y equals ax squared plus bx plus c, or sometimes they use function notation. Same thing. The special thing about quadratic equations is that they have a squared term, an x squared term. So they'll never have an exponent higher than 2 in the equation, and you will always have an x squared term somewhere in the equation for you to know that it is quadratic. Another way it can be written, this is standard form, and we'll come back to this a little bit later. It can also be written in vertex form. And this is vertex form, and again, it could be in function notation instead. Either way it's written, this is the same types of equations. This is still quadratic. See the square term right there? Quadratic graphs are always parabolas. And remember, a parabola can either open up or it can open down. Now, do you remember what causes that? Remember, that's the A term. In either place, the A term tells us whether it opens up or opens down. If A is positive, that is if it's greater than 0, your graph is opening up. If it's negative, then your graph is opening down. Now, in that parabola, we have a special point at either the very bottom or the very top, depending on whether it's opening up or down, and this is called the vertex. And this is an actual point. And we're going to talk about how to find that in either standard form or vertex form in a few minutes. But if you're looking at a graph, the vertex is the point at the lowest point if it's opening up, so we call it a minimum if it's opening up. And it's at the highest point if it's opening down, so if it's at the highest point, it's called the maximum. Another thing we have in these parabolas is we have an imaginary line that cuts right through the center. It goes right through the vertex, and this is called the axis of symmetry. And the axis of symmetry is always an equation because it's a line. And since it's going up and down, since it's vertical, it's a vertical line, which means it's x equals some number, and that number actually is the x value of the vertex because it always cuts right through the vertex. So the axis of symmetry is always an equation, it's always a line, so it's always x equals some number, and that number is the x value of the vertex. Okay, so now that we had a real quick review on graphs, let's actually look at a graph and see if we can pick out some of these different things. Okay, so the vertex right here is right at this point. Now, this graph is opening up, which means when we looked at the equation, A would be positive. And since it's at the lowest point here, this is a minimum. And to tell what the vertex actually is, I just need the point. So the vertex here is x is 2, and y is 1, 2, negative 3. The axis of symmetry is that imaginary line that goes right through the center. Remember, it always goes through the vertex, and it's going to be x equals the x value of the vertex, which is 2. Now, the reason why, look at this line. Everywhere this line is, x is 2, all along that line. The y-intercept. The y-intercept is where the graph crosses the y-axis, which would be right here. The y-intercept is what y equals when x is 0. So when x is 0, y is at 1. Now we're not going to worry about domain and range for right now. Let's talk about the x-intercepts. Now here it's kind of hard to see what they are, but the x-intercepts are special. The x-intercepts we also call the roots or the zeros. The x-intercepts are where the graph crosses the x-axis. These are the solutions when you are solving out the quadratic equation. Now on this graph, they're not great to see. We know that this one is somewhere between 0 and 1, and we know this one is somewhere between 1, 2, 3, 3, and 4. All right, let's try another graph. Okay, now this parabola is opening down, which means that A was negative. My vertex is at the highest point, so this is a maximum. Where actually is the vertex? Well, it has an x value of 1, 2, 3, and we went to the left, so that's a negative 3, and a y value of positive 2. So the vertex is always a point. Make sure you have your x and your y. Axis of symmetry, this is that imaginary line that cuts it in half, and remember it's always x equals whatever the x value of the vertex is, because it's right here at x equals negative 3. The y-intercept. Y-intercept is always what y equals when x is 0. When x is 0, y is negative 1, 2, 3, 4, 5, 6, 7. And then the x-intercept, so the solutions will be found here and here. Again, there's 2 of them. It crosses twice, but it's hard to see exactly where it is, somewhere between negative 1 and negative 2, and then between negative 4 and negative 5. Let's talk a little bit more about equations in standard form. So we can find the vertex, the axis of symmetry, and the y-intercept just from standard form. So if it's in standard form, I know it's in standard form if it's in this ax squared plus bx plus c form. And to find the vertex, I need to use this formula right here. The x value of the vertex is the opposite of b over 2a. And then when you have the x value, you're going to plug it back in and solve for y. So let's try that with this equation. So I'm going to see, first of all, what a equals, b equals, and c equals in this equation. So a is the coefficient in front of x squared, so that's negative 3. B is the coefficient in front of x, so that's 6. And then c is the constant at the end, that's negative 1. So if I find the opposite of b over 2a, well, b is positive 6, so the opposite of that is negative 6. 2 times a, so 2 times negative 3. So we have negative 6 over 2 times negative 3 is negative 6. Negative 6 divided by negative 6 is positive 1. That means the x value of my vertex is positive 1. Now we know the vertex is a point, so I need the y value as well. We're going to take that 1 and we're going to plug it into everywhere there is an x in this equation. So I'm just going to rewrite this equation. Oops, that's a negative 3. Always be careful with those negatives, easy to drop. And everywhere there's an x, we're going to put a 1. So plus 6x, so 6 times 1, minus 1. Order of operations, let's do exponents first. So 1 squared, that's just 1. 1 times negative 3, that's still negative 3. 6 times 1, that's 6. Minus 1, all I have is addition and subtraction. So if I start from the left, negative 3 plus 6 is positive 3. Minus 1 is positive 2. So my vertex for this is 1, 2. Axis of symmetry is always x equals the x value of the vertex, so it's just x equals 1. Now, the y-intercept. Remember back when we talked about on the graph, the y-intercept was always what y equals when x is 0. Well, if I plug in 0 for x, if I plug in 0 for x here and here, well, that's going to make that 0. That's going to make that 0. So all I'm left with is, so guess what? Anytime you're looking for the y-intercept, see this value right here, that is always your y-intercept. So the y-intercept here, when x is 0, y is negative 1. So your y-intercept is always what y equals when x equals 0. And so if it's in standard form, all you got to do is pull that 1 right there. If we look at this graph, and we're not going to graph it, but just thinking about it, is this graph going to open up or down? And how do you know? Well, remember, we need to look at the a term. The a term here is a negative 3, which means it opens down. Does that mean this vertex at 1, 2 is a maximum or a minimum? Well, if it opens down, that means it's going to be a maximum. Okay, let's look at a graph in vertex form. So in vertex form, this is vertex form right here. And vertex form is called vertex form because the vertex is actually in the equation, which makes it nice and easy, but the only thing we have to remember is that negative right here is part of the equation. Because it's part of the equation, when I am pulling the vertex from this form, I find the x value of the vertex right after the x, and the y value of the vertex is a constant at the end. What I've got to be careful about, though, is since that negative is part of the equation, I ignore that negative, or I do the opposite sign if you want to think about it that way, to get the correct value of x in the vertex. So since negative is part of the equation, I'm going to do the opposite sign. The x value is 3. And then the y value of the vertex is just always whatever is added or subtracted at the end. So we're adding 6, so it's a positive 6. So the y value of the vertex is always this number that's added or subtracted, the constant at the end. The x value is always inside the parentheses with x. Just make sure you do the opposite sign because of the negative in the equation. Axis of symmetry, well, that's going to be x equals the x value of the vertex, so x equals 3. Would this graph open up or down? Well, A we find right in front of the parentheses with x minus h squared. That's the same A from standard form. And since A here is a negative 2, again, we have another graph that opens down, and again, we're going to have another maximum. So looking right here at the A term in front, that's going to be the same as when it was in standard form to tell you whether it opens up or down. Okay, this week you are just going online and you're going to take a quiz on quizzes over these things. So do your best. You can take it up to 5 times. Let me know if you have questions. Come back and revisit this video if you need a little refresher before you try the quiz again if you need some help. All right, y'all have a good week.